What is an alcohol? Molecules, they are molecules with no H group, okay? This is a hydroxyl group, or hydroxide, okay? And they end in, the names end in "ol", okay? The names are based on alkanes, okay? So that's 1 carbon, 2 carbons, 3 carbons, 4 carbons, 5 carbons, 6 carbons, 7 carbon, 8 carbon, okay? Excuse me. So I've drawn out the first two. I'm not going to bother drawing out the rest because you know them. And I've got other videos showing those. So, I should say that all of these are, these are alkanes, okay? So, right, so the alcohols, you have so these are the alcohols. This is methanol. So I won't fill all the hydrogens in, but all the hydrogens should be filled in, okay, in each of them. So this is methanol, okay, which is poisonous. This is ethanol, which is the most important. So you see how the name is like methane, but we replace E with OL. And this is ethane, but replacing the E at the end with OL. This is propanol. So the E that would go here is replaced by the OL, propanol, and then butanol. And then that's pentanol. And that's hexanol. And that's peptanol, peptanol, and this is octanol. Okay, so the E at the end of ethane, methane, propane, butane is replaced by OL. Okay, so it's the OH group here that states that it's an alcohol. So like with any organic molecules, when you see, you identify what they are by looking for the functional group, okay? So yeah, so methanol's poisonous, ethanol is most important, okay? Can you guess why? It's because it's used in all alcoholic drinks, beer, whiskey, gin tonics, wine, everything. Gins, sort of vodka, brandy, alcoholic drinks, and these other ones are just different, basically derivatives of it. They're longer chains, so these are all found in laboratories. So yeah, that's the alcohols. You need to practice writing these out so you learn how to write them for the exams. All hydrogens should go on. All hydrogens, okay? I'm just not doing it all because it's not what I want to show you in the video, but normally I do, okay? So uses of Right, so we've done alcohols. Now there's carboxylic acids. Okay, so these are identified, these are, the carboxylic acids are identified by the COH group, or C, okay, group, which is the carboxylic group at the end of the molecule. Well, alcohols can also be in the middle of a molecule. I put them at the end, but they can also be any of the carbons. Same with acids. So they're again named after the alkanes. So the simplest one is, which is named after first alkane methane, methanoic acid. So the E is replaced by oic, okay? OIC. That's methanoic acid, and then ethanoic acid. Ethanoic acid, okay? And so on. And they go all the way up to octanoic acid. And the basic formula for these is, so you get CnH2n2, okay? So there's always two oxygens, CnH2n. So if you have hexanoic acid, which is N equals 6, so you have C6H12O2, okay? That's hexanoic acid. Using acids and alcohols, so again, the carboxylic position, if you have like that, you could have the carboxylic acid, sorry, you could have the carboxylic group, it could be at the end, but it could also be in the middle, like this. So I think in your course you're only taught to put them at the end, but they can be in the middle. So this wouldn't actually be hex, this would, sorry, that's 1, 2, 3, 4, 5. Yeah, because there's a 6 carbon here, this is an isomer of, this is actually an isomer of hexanoic acid. Because instead of the carbon being the end of the molecule, so it's 6 in the row, is actually in the middle, but the 6 carbon, so it's an isomer of hexanoic acid, okay? So we've got acids and alcohols. What can we do with these? Well, there is something we can do with them that's actually pretty exciting and very memorable, especially for your nose. You can make esters. So an ester is basically an alcohol plus a carboxylic acid leads to an ester. Okay? Because water is let off, these reactions are called condensation reactions. You know, at night time when you breathe out in the window in the morning, the window is covered in water. That's condensate. It's all the breath coming out of your mouth, coming out of your lungs. So you get condensation on the windows. It's the same sort of idea. When these two react to form esters, water is released, and that's why we call it a condensation reaction. Okay, so basic one, if you have ethanol plus ethanoic acid, that leads to ethyl ethanoate. Okay, so the alcohol part gets renamed "ile", okay, and the acid part, the OH part, gets renamed OH, okay? So the alcohol becomes "ile" and the OH part becomes OH. So, and you get plus some, so when you get these joined together, you basically get, okay? So again, oxygen are 2 bonds, hydrogens are 4, carbons are 4, hydrogens are 1, oxygen is 2 bonds, okay? So yeah, this is from the alcohol, and this part is creating the acid, okay? Excuse the stops and pauses, my batteries keep running out. So anyway, so yeah, the esters made, okay, plus water. So why is this important? Esters are very sweet smelling, okay? It's been quite a while since I smelt one, but they're actually very sweet smelling. They are very, very nice, pleasant smells. So for example, the scent, this is the ester, okay? So your propyl, as examples, propyl ethanoate smells of pear, 3-methyl-bute-1-ol ethanoate smells of banana, octyl ethanoate smells of orange, and methyl butanoate smells of pineapple, okay? So to show you how these work, if you take methyl, okay, and these react to form, so this hydrogen here, so that hydrogen and that OH group come off, okay? So you get that oxygen forming a bond with the carbon, and the double bond oxygen of the carboxylic group. Okay. So that's the methanol, and this is the butanoic acid. The methanol forms the methyl part, and the butanoic acid becomes the butanoate. And I'd love to smell that because it smells of apple pineapple, okay? It's a really nice scent on that. And you get ones which smell of peach, I think. And they're very memorable because it actually smells of the fruits. And so I hope you understand that. You got the hydrogen comes off the hydroxide group and combines with the hydroxide and the carboxylic group to form water. So the oxygen of the hydroxide group joins with the carbon here, and you get the rest of them all. So that's how they join together. And this link, that's the ester link, okay? And you get, and they're used in many products. One, for example, contains, there's when you have headaches, aspirin, which is actually this. So that is the ester link, okay? This is an aromatic carboxylic acid. Okay, I have, how does this work? I think part of this molecule interferes with, I think it's a serine residue in an enzyme, and it prevents inflammation. I'll come back to that later, but I think that's how it works. So anyway, you've got, so that's aspirin, which uses an ester, and you've got girls might use nail varnish. That uses esters, ethyl ethanoate. And athletes may use oil of wintergreen, used by athletes. I've used this stuff actually. It has a strong scent, which is using methyl. Use it for strains and sprains. Methyl acylate. And I don't remember the formula for that. I'm not sure what that is, but this is all the wintergreen used by athletes. So nail varnish uses ethyl ethanoate and aspirin, which we're all familiar with. Yeah, this reacts with a serine, I think it is, in a and controls the release of chemicals involved in preventing inflammation. So, yeah, that's basic esters and their uses. So ethyl ethanoate is nail varnish. To unmake esters, you hydrolyze them, means you add water to them, okay? So I think I actually call this quits, make this in a new video. Otherwise the video will become ages. So, okay, I hope that's a help. But also in the new video I'm going to talk about how esters are hydrolyzed, which means added plus water. They convert back to the alcohol and acid, okay? Aspirin is contained in modern aspirin packets. They're packed into aluminium foil sealed boxes, okay? And the reason why they're in sealed boxes or packets, which are completely sealed, is to keep them water out, because when water gets into aspirin, if it gets to it, it reacts with the aspirin, hydrolyzes it, and breaks it up into the acid and alcohol again. So if you expose aspirin to air for too long, it actually goes off, because aspirin becomes acid and alcohol, and it tells the acid is foul smelling and sort of rather not very pleasant. So that's why aspirin is packed in foil sealed packets or air sealed packets. If they aren't foil, it might be paper, but it'll be watertight paper, like with probably grease, sort of proof paper in the back of it, greased paper, so it's basically they don't let any moisture in. So yeah, so it also means you shouldn't really leave aspirin lying around in your bedside table for overnight, because it starts to hydrolyze. If you take aspirin out of a packet, take it straight away, leave it out overnight, and it'll actually ruin them. So anyway, yeah, so it's part of this inhibits an enzyme. So anyway, have a good evening.